So in this video I'm going to cover two things. The first thing is how we are going to solve this problem. So we are going to find the solution and do some live coding here. So solution and the coding. And the second goal is to see how we should behave in a real coding interview. So let's get started. So remember, in a real coding interview, the first step is always try to understand the question. If there's anything unclear, please bring up the question to the interviewer, and at the same time think about some edge cases. So let's take a look at this question. So given an n by n matrix, return true if the matrix is Toeplitz, so otherwise return false. So a matrix is, I just say Toeplitz, if every diagonal from top left to the bottom right has the same element. So for example, let's see this matrix, everything on this diagonal is the same, similar here, same here, same here, same here, same here. So this one is going to return true, and this one is going to return false because on this diagonal the number is not the same. So let's see some constraints. It says that the matrix dot, so M is matrix dot length. It's a m by n matrix essentially, and m by n is between 1 to 20, so this is never going to be an empty matrix. So each number is between 0 to 99. So what if the matrix is stored on the disk and the memory is limited such that you can only load at most one row of the matrix into the memory at once? And also it says, what if the matrix is so large that you can only load up a partial row into the memory at once? So the follow-up is essentially saying that the matrix is very large, even though a single row is very large. So which means you cannot even load a whole row into the memory at once. So let's just treat in that way, which is more difficult. Try to find the solution for that part. So for a solution, how are we going to solve this problem? So essentially, I would say on the same diagonal, there is a common characteristic, which is if you use the row number minus the column number, then it is going to be the same. So for this diagonal, row number minus the column number is going to be 0, and for this one, row number minus the column number, it is equal to 1. This one, row minus the column, it is equal to -1. So what we could do is we could use a hash map. So the hash map is row minus column, and the value is the corresponding number. So in this way, every time we go through a corresponding place, let's say matrix ij, so we put the I minus j into the map, and we put the corresponding number into it if it doesn't exist in the map. Otherwise, we will try to see if it is the same with row minus column as a key. So in this way, the runtime is going to be O m by n. For the runtime, the space-wise, it is going to be O m plus n. So in this case, what we could do, so in this case, we can also satisfy the condition, which is we can only load a partial row into the memory. So this is going to fit in our solution, I would say. So having said that, let's do some coding work for this. So for coding part, we care about the readability, of course, the correctness of the code, and also don't be too slow. So we are going to have the map integer to integer. So I would say this is diag to num map to Hashmap. So we go through everything. So I is equal to 0, I is smaller than matrix dot length plus I for each of the column. J is equal to 0, J is smaller than matrix 0 dot length plus J. So if let's just define the DAG, which is represented by I minus J. So if the DAG num if it doesn't contain a key, you're going to put it into the key, into the map. So diagonal num map dot put the and also the matrix ij into it, and we also, and otherwise we will need to see whether it is the same. If it is not the same, then we are going to return false. So if diagonal map dot get that is not equal to matrix ij, then we are going to return false. And finally, we are going to return true. So let's do some testing. For testing, for simplicity, we are just going to rely on this platform to help us to do the testing. So let's do submission. Alright, so it seems that everything works well. So that's it for this coding question. If you have any question about the solution or about whatever, feel free to leave some comments below. If you like this video, please help subscribe this channel. I'll see you next time. Thanks for watching.